So to get started here, we're going to have our next sponsor presentation from NetApp, Jeff Baxter, talking about solving I/O challenges.
So thank you very much, and really appreciate the time to be here. As you might notice, if you were being eagle-eyed on the agenda, Steve Hochberg wasn't able to make it, so I'm filling in. My name is Jeff Baxter. I'm a principal architect with NetApp. I work out of our Sunnyvale headquarters here, primarily with our public sector customers, so higher education, federal, state, local, a lot of the national labs in this particular space. So I'm going to talk a little bit for the next 20 minutes just about NetApp and what we do in terms of high-performance computing and sort of solving the I/O challenge part of the equation and the storage part of the equation. So really for us, and I don't need to even go over this slide significantly with you because you're the ones driving a lot of these challenges. For us, really, the challenges of HPC that we can help solve is this influx of big data, right? And big data is one of those industry buzzwords. If you give a storage presentation and you don't say big data, cloud, and flash during it, you get disqualified. So I've covered that right now, so I'm good. The marketing team can note off that I've mentioned all three of those words. But really for us, big data is about this constant explosion of terabytes and now petabytes and now exabytes of data. You know, NetApp has a customer out there that has an exabyte of data on the floor. So it's no longer a theoretical notion. We have another customer with more than 800 petabytes on the floor. So these numbers are no longer theoretical, they're actual, and they're growing rapidly. The number of multi-petabyte customers that NetApp has is counted on way more than number of fingers than I have. So as we're getting this flood of big data, the question really is about what can we do on the storage side, what can we do on the vendor side to keep pace with that amount of data. And it's not just about keeping pace with the spindles, because most all your storage vendors use the same spindles, whether they're Hitachi, Seagate, Western Digital, whatever. It's how can we build a storage management framework on top of that that allows it to scale. So one thing you might not be familiar with, how many of you have actually heard of NetApp? I'm always curious. Okay, good. That's actually more than I expected in this particular context. And the reason is because a lot of people don't think of NetApp when it comes to HPC. The truth is we've had a broad and long engagement with the HPC community, with customers out there ranging from national labs to enterprise customers that are using HPC-like applications for simulation. And we also have a whole huge swath of OEM partners. So in a lot of cases, we have customers who are using NetApp storage that don't even realize it's NetApp storage. We're actually the #1 OEM provider of storage out there in the enterprise today. The other key thing that happened with NetApp is a 20-year-old company, primarily that's been focused around enterprise storage. About a year, 2 years ago, we purchased the Ingenio portion of LSI, which has made a lot of the high-performance computing storage that's out there. So that became our E-Series offering at NetApp. So if you've ever heard of Ingenio or LSI or any of those OEM products, that's now part of NetApp. And NetApp, being the #2 and rising storage provider overall in the world, is firmly committed to embracing, extending, and growing that storage for the HPC space. So one customer example is you heard about Sequoia this morning. NetApp E-Series storage is the storage behind the Sequoia Supercomputer. We have 55 petabytes of usable storage on the floor. I will say, when you actually get to go see it, 55 petabytes doesn't look like nearly as much as I thought 55 petabytes would look today. It's a huge number, but it actually, with some of the dense enclosures that NetApp is able to offer, doesn't actually take up nearly as much space, power, or cooling as you think, and that's one of the things we'll talk about how we did that. Furthermore, it's always amazing to me when we hit, they're arbitrary numbers, but being able to say this was designed and has now hit 1 terabyte per second of bandwidth is a huge achievement. So normally for our individual storage systems, we talk about 3 gigs a second, 6 gigs a second, 12 gigs a second, those sort of numbers. With the sort of modular, scalable architecture we built under a clustered file system with Sequoia, we were able to achieve 1 terabyte a second of overall sequential bandwidth through the system. So definitely a good proof point in scaling with what NetApp brings to offer against these I/O challenges. So really what we're trying to address is the problem of what keeps you up at night, right? In terms of making sure that the I/O on the back end is not the issue, is not the gating factor. So getting bigger jobs done in a shorter amount of time, getting more jobs done in a shorter period of time or the same period of time, and making sure that that system is highly reliable, right? Whether it's individual component failures, whether it's disk drive failures, when you start talking about thousands and thousands and thousands of disk drives, you will have a disk drive always failed. just the rule, especially larger and larger disk drives. So how can we engineer around that? How can we make things even more reliable? How can we make sure that we've hit every efficiency we can in terms of floor space, in terms of heat and cooling, in terms of just raw density, in terms of number of tiles? So that's something we've engineered to. And finally, how can we drive down the acquisition costs so that your dollars per IOP and dollars per gig are as best possible? So what we've really focused on is trying to change the name of the equation from these monolithic solutions, so these very large multi-petabyte storage arrays that come in a chunk, right, that perform very well, and I'm not saying anything negative about them, but it's a very monolithic sort of approach, to more of a scale-out approach where you build out in these smaller, scalable building blocks, right? So a modular block, each one taking a very low power, taking up a relatively small footprint. So, you know, a 4U footprint, 60 drives, all the controllers you need to drive those drives all in one box, and highly efficient in terms of the power supplies and the overall draw of power. So obviously, we believe that this is the right solution, and this is where we put basically all of our resources behind, is building out this scalable building block. You know, people ask us, what really are you trying to do for the HPC space? And we're not trying to solve all the challenges of the world. I think that's your job. But what we are trying to do is build what we call the perfect storage brick, right? We want to give you essentially a 4U brick or 2U or whatever it is that gives you as much I/O as we can humanly drive out of the drives in that unit, takes up the least power, and lets you put the most drives in the fewest amount of space. So that's really what NetApp's been committed to with our E-Series line of products. So if you look at our products, not to do a whole deep dive on the actual product set, but the premier product we're using at Sequoia and at all these customers that are using our E-Series product line is our E5460 array, which combines two extremely high-performance controllers in the back with 60 drives and 4U of space, lets you use basically 50% the vertical space of comparable solutions because you're not using up additional space for controllers. They're all embedded. You've got 60 drives in the same 4U space in a standard 19-inch cabinet. So this isn't an extremely deep cabinet. It's not one of those you need to carve out special space in your data center. It works on perfectly normal floor tiles. Now, if you load an entire rack up with these, they have to be reinforced floor tiles unless you want to, you know, drop it through the floor. But works on normal floor tiles, normal HVAC, normal power, to be able to provide dramatically better reads, dramatically better writes, and improve performance under controller failure. So you just build up a system out of these blocks. So any one of these blocks can do up to 6 gigabytes a second in sustained read bandwidth, and in terms of sustained writes, up to 3.6 gigabytes per second in bandwidth. So the nice thing is these scale out linearly. So because they're very modular, each one I add to the rack goes ahead and ups the overall amount of bandwidth for the system. There's no bottleneck at a controller layer where you can add a certain amount of shelves and then you've got to add a whole new storage array. Each one of these is capable of exporting, say, LUNs to a Lustre or GPFS or StoreNext or any file system you want, and giving that full read and write performance to that clustered file system that the drives are capable of producing. So, you know, it's basic math at that point. A single 4U system is going to deliver 6 gigs a second, 2 systems, 12 gigs a second, 5 systems, 30 gigs a second. If you fill a rack with 10 of these, a standard 42U rack with 10 of these systems, you're going to end up with 60 gigabytes a second of performance. It's pure linear scalability, which is exactly what we believe is the correct solution for an HPC environment. Just scale up with node after node after node, and be able to scale up in a much more reasonable and cost-effective manner as opposed to having to front load all of the cost for all of your bandwidth up front out of controllers. So that, as I mentioned, just lets you scale in much smaller chunks. So you can add just one controller at a time, or you can bring in a whole rack of nodes at a time. So if you want to expand by just a little bit, you're not buying a whole new controller and whole new storage. We build all of that with the concept of open storage nodes. So we put basically a server running the Lustre file system or whatever clustered file system you might want to run on top of each one of these nodes. Typically InfiniBand attached, although we also have customers who use SAS connectivity. We try and be as incredibly flexible as possible because what we found is one size fits all doesn't work in the HPC environment. So for adding nodes, you can use SAS, you can use InfiniBand, you can use Fiber Channel, you can use iSCSI. Basically, any sort of attachment method you want attaches directly to these scalable building blocks. And then from there, you just scale out your open storage node and your storage array in those modular increments to meet whichever bandwidth challenge you want. We do also offer one of the things we're trying to do is in some ways expand access to HPC, especially into enterprise. We want to provide these custom solutions for people who have the expertise to be running clustered file system, most of the people in this room who are very familiar and will likely run and roll their own. For other customers, we want to provide options like our high-performance storage rack, where we bundle in NetApp E-Series storage along with those open storage controllers running the Lustre distribution, so that customers can, if they aren't as familiar with Lustre, or they don't want to have to go through that entire process, can buy a pre-bundled rack, mount up their Lustre clients, and have an exported file system within a couple hours. It's certainly no substitute for a build your own, built by experts, but we're trying to in some ways democratize it and get it out to enterprise that may want to use this for missions outside of the traditional scope. So in that particular case, we would end up with a pre-built rack, pre-built open systems running Lustre across these file systems with a smart pre-wired, pre-cabled, pre-shipped design that simplifies management, has a built-in GUI for Lustre management, has a built-in system manager so that people can get started sooner rather than later on actually using this to run jobs on top of the system. A couple things I want to mention around areas we've innovated over the last year or so in the E-Series product line, for those of you who are familiar with our line. One thing that we're doing that's very interesting, and one thing that's been of big value in the Sequoia installation is this concept of dynamic disk pools. So I think probably a lot of you are aware, but if not, the traditional concept of RAID is slowly but surely breaking down, right? The process of rebuilding a drive has gotten no quicker. From when I had a 250 gig drive to a 4 terabyte drive, it's just gotten 16 times worse. Okay, so now a drive failing can literally take days to rebuild under traditional RAID. And that's a real issue for a couple of reasons. One, as you're aware in a clustered file system, a lot of times the slowest node is the one that sets the overall pace for the file system. The second is if your drives are taking multiple days to rebuild and you have a multiple hundred or multiple thousand drive system, just your average mean time between failure means you're always going to have a drive in failure mode. And it opens you up to the ability when, even if you're using RAID 6 or some other data protection methodology, the chance of double drive failure or triple drive failure goes from being a statistical abnormality to being a statistical certainty at some point with that many drives and that long a rebuild period. So one of the things we've done on the E-Series is introduce this concept of dynamic disk pools, where we've gone ahead and stripe the data and chunk the data onto every drive. So instead of having dedicated parity drives, we actually split the parity workload across every drive within the system. We get the same protection against disk failure, but we get all the drives working together during a rebuild. Instead of trying to rebuild and design and calculate parity and push it all back into one drive, which necessarily gates the rebuild to one single drive's bandwidth, we do the rebuild on every drive. So what that means is we end up rebuilding whole pools of storage. Instead of taking days, we can do it in less than an hour. Okay? That means that the performance impact on the clustered file system while we're doing the RAID rebuild is necessarily lessened because we're spreading the load across every piece of the file system. It means that the data protection is dramatically improved because the time is lowered, which gives you a much lesser chance of ever experiencing a double disk or a triple disk failure because you're just not exposed for nearly as long. And finally, it gives you significant versatility. Instead of being tied into specific RAID groups made up of specific constructs of 1 terabyte or 2 terabyte or 4 terabyte drives, right? You can suddenly make a RAID group of virtually any size because you're using just small chunks from every drive to build that logical construct. So this is something very new that NetApp has brought to the table with the E-Series. It's the whole concept. We're trying to abstract from the physical construct of the disk drive and give you RAID rebuild that takes advantage of the entire throughput of the system and individual LUNs that take advantage of any particular size you want without particular regard for the disks being used in the system. So we can certainly talk more about that offline, but this is kind of an exciting thing. You know, it's one of those things that only, I guess, disk firmware people get excited about at night, right? But in terms of actually moving RAID forward into the next generation, we think this is a significant advance. The other big change is, you know, Flash is changing everything, right? We are slowly but surely reaching the point where your traditional 15K spinning drives are slowly being replaced. How many of you have SSDs in your laptops out there? Okay. So consumerization is driving down the price of flash, as I'm sure you're aware, as we're moving to eMLC flash, moving to potentially TLC flash. We have the consumer laptops to thank. We have Apple and the Android tablet makers to thank for driving down the price of flash. We've quickly reached the point where on a dollars per IOP basis, Flash and SSDs blew away spinning disks a long time ago. On a dollars per gig basis, we're still in a situation where the 15K drives make sense, but within the next 5 years, that's not going to be true. Now, the really dense drives, the 3 terabyte, 4 terabyte, 6 terabyte drives, we're not sure where that horizon intersects yet, so there's always still going to be a mix. This is my guess, probably for the next decade. But for true performance, solid state is where it's going. So the question is always where to deploy flash. And the answer I've always given at NetApp is yes. Right? There's no one answer. And I think any vendor who comes and says you should put flash exactly here, it's the best place to put it, isn't looking at all the myriad architectures. So from a NetApp perspective, whether you're using our shared infrastructure product, the one that we traditionally have used for home directories, for exports, where you can put flash out on the server layer, you can put flash in the controller, you can put flash either as persistent disk pools or as cache on a disk pool. Or if you're looking at our dedicated, our E-series storage, and you're looking at all SSD offerings of that, or you're looking at using flash as a cache on top of it, in either case, flash is really reaching, I think, an inflection point where a lot of our HPC customers are at least using flash for their metadata and their metadata controllers, if nothing else, and they're slowly but surely starting to look at, does it make sense based upon my IOPS and my dollars per IOP to move at least a portion of my file system or some of my clusters over to solid-state storage? Because one of these 2U storage arrays built upon solid-state can make hundreds and hundreds of thousands of IOPS. So especially on random operations, moving to solid state has become incredibly important, and just the direction the industry as a whole is moving, and that NetApp is taking a leadership role in pushing. So one of the things we have done in the past year just to implement that is we've made it so that solid state drives placed in one of these arrays, you don't necessarily have to dedicate and manage separately. You can use them directly as a read cache. So just by adding a couple solid-state drives in any one of our E-series arrays, you can designate that as a read cache, and it will take some of the burstiness out of traffic. So if you have certain blocks or certain files that are being hit very rapidly, we can go ahead and accelerate those by automatically moving them into solid state. So it's very familiar. If you've seen things like hybrid solid-state hard drives for laptops, different things like that, right? It's a very similar concept but applied to enterprise storage. So you put a couple solid-state drives in along with your dense drives, and you get sort of a best of both worlds between capacity and performance. So on that note, and I believe I'm right about at time, so just a couple closing thoughts that I'll leave you with. And if you want to discuss any of this further, we are sitting next door in the fabulous vendor showroom, so please feel free to stop by. So really what we're looking at is that we have to provide, on the I/O level, intelligent, reliable storage that hits the right performance mark. We believe the modular storage is optimal, and that is to say storage that has everything you need in terms of controllers, drives, and performance built into modular building blocks that you can scale up with. Purpose-built is a must. So we've been in this industry as part of LSI. That acquisition has been in this industry for 30 years, right? Purpose-building systems for high-performance computing in the terms of our E-series line. So absolutely a must in that sort of regard. And finally, and this is something looking forward, flash is changing everything. And we're actively riding that wave, and it's really interesting where it's going to be going, and you can expect a lot more coming from NetApp in the future on flash. Thank you very much for your time, and I appreciate the opportunity to be here.